All right, guys, and we are rolling along on CLT practice test number 2 with question number 114. It says, which of the following is equivalent to 2 sine squared theta plus 1 over cosine squared theta over tangent squared theta? So because we have these sine squared theta and cosine squared theta, I want you to look on your reference sheet for your CLT exam and look for something that looks kind of similar to that. And you should see something that looks like sine squared theta plus cosine squared theta equals 1. So this was for the question above. Actually, I'm going to erase that out. I want some more space. Sine squared theta plus cosine squared theta equals 1. And on CLT, they love to give you the rewritten version of this, right? So if I wanted to get sine squared theta by itself, I can subtract cosine squared theta from both sides of the equation, minus cosine squared theta minus cosine squared theta to give you that sine squared theta, those will cancel out, equals 1 minus cosine squared theta. And you see why I took the time to do that right here. They gave you this. So we've got, right away, we can start simplifying that. That's just given information. 2 sine squared theta plus, instead of writing 1 minus cosine squared theta, I'm going to write it as sine squared theta because we just proved over here that these are equivalent. So I'm allowed to do this. Tangent squared theta. Okay? And next, I can rewrite tangent squared theta. And this is given to you on your reference sheet that the tangent of theta equals the sine of theta over the cosine of theta. So when we look at this here, I can rewrite this. Let me see here. 2 sine squared theta plus so if I wanted to take sine squared theta and divide it by tangent squared theta, let me just look at this right here. If I wanted to say, I'm just going to put some squares, sine squared theta divided by this, right? Divided by this. I'm going to treat this like dividing fractions where I can say, okay, keep, change, flip. That becomes sine squared theta times, flip it, cosine squared theta over sine squared theta. And then you have, look at that, you have sine squared theta across from sine squared theta. So we can simplify. I used to tell my 5th graders, this is a middle school shortcut. But now you guys are seniors, so this is an old shortcut for you guys. So all of that really just equals cosine squared theta. So I'm going to write this All of this simplifies just to cosine squared theta. And I want to start looking at my answer choices, and that's not there. But instead of writing out 2 sine squared theta, can I just call that sine squared theta plus sine squared theta plus cosine squared theta, right? These are equivalent. Just put a squiggly line through that. It's looking a little messy. And then what do we have right here? Sine squared theta plus cosine squared theta is equal to 1. So all of this is just sine squared theta plus 1 because this piece right here is equivalent or equal to 1. So we're done with question number 114. And we're looking on to a sequence on question number 115. What is the next term in the following sequence? We've got negative a half, 1, 1/6, and then 1/13. So what is going on with these numbers, right? 1 over 2, that's negative. 1, since all the other numbers are fractions, I'm going to rewrite 1 as 1 over 1. And then I'm going to write 1 over 6, 1 over 13, and next would be 1 over what? 1 over what? That is the question. So what is our pattern going on with these numbers here at the bottom? I'm going to go backwards. That's 6 taken away from 13. 13 minus 6, that's 7. So they added 7. 1 to 6, 6 minus 1, they added 5. And 1 down to negative 2. For that one, they added 3. And those numbers are in a pattern, 3, 5, 7. So for the next one, what would you add to the denominator, to the bottom? 3, 5, 7, you'd add 9. And 13 plus 9 is 22. So the next number in the pattern is 1 over 22. And we're going to roll on to question number 116, which says, which of the following is always true for integers w and z if w is greater than z and z is negative? So I'm going to say, okay, w is greater than z. What if I said, okay, w, your w, your 6, and z, your negative 5. I'm just going to make up some numbers, right? Z is negative and w is greater than z. Okay, so is it always true that w squared is greater than z squared? 36 is greater than 25. That would always be true. Well, that's true for mine. Wait, would it always be true? W is greater than z. What's still greater than z? What if w was 2 and z was negative 5? Then would it be true? W squared. 2 squared would not be greater than negative 5 squared, because a negative times a negative would become a positive. So not always, my bad. That is only sometimes true. Sometimes true. And then we've got w plus 1 is greater than z cubed. Z cubed. Oh, okay. So when z is cubed, negative 5 cubed, it's going to be a negative times a negative times a negative. It's going to stay a negative 125 for my example. And if w is greater than this, right, then it's going to be more than negative 125. So this one is always true. B is always true. And then C, negative W is less than Z. That wouldn't be true for my example right here. Negative 2 is not less than negative 5. It's greater. So that's a counterexample. And then W squared is less than Z cubed. Let's see. W squared less than Z cubed. That's never going to happen because we just said Z cubed is going to be a negative and anything squared is going to be a positive. So a positive can't be less than a negative. So that's never true. And whoopsies. Looks like I'm out of time for the rest of these questions. So I'll see you back on the next one for our next round of questions.